Hello everyone and welcome to the Earth Network's 2020 Hurricane Outlook webinar. We're going to be getting started in just a few moments and we're going to wait just a few more minutes for everyone to log in. And as we wait, we're taking a live look at weather conditions around the US with Earth Network spheric maps. So just sit tight for a few more minutes and we're going to get started. Hello everyone, we're just about to get started. This is the 2020 Earth Network's Hurricane Outlook. Stand by for just one more moment. Hello again, this is the Earth Network's 2020 Hurricane Outlook. Thanks for joining us today. I'm your moderator, Anna Porteous, Director of Marketing here at Earth Networks. Before we get started, I'd like to go over a few points. We will be taking questions today. If you would like to ask a question, please use the GoToWebinar question section in the control panel on the right of your screen. If you have questions or need more information after the webinar, please email us at info@earthnetworks.com and we will follow up with you. You are in listen-only mode. Participants are muted to minimize background noise. If you have any trouble hearing us, we'll try to help you. Just chat into the question panel or use the chat feature and we'll try to help you with that. This webinar is being recorded. All registrants will receive a link to the recorded webinar and slide deck in an email that we will send out after today's session. And now a little bit about our company. We are Earth Networks and we operate the world's largest proprietary weather observation and lightning detection network. Our vision is a safer, more prosperous world, and we help global organizations automate decisions through weather intelligence. And here are just a few of the organizations that we work with. Hurricane season begins on June 1st and lasts until November 30th. Every spring, our meteorologists analyze trends and all kinds of weather data to create the Earth Network's Hurricane Outlook. It's a collaborative effort backed by an amazing team. And this is the Earth Network's 2020 Hurricane Outlook team. We provide 24/7 custom threat forecasts and seasonal outlooks just like this one for major sports teams, schools, aviation, and enterprise clients, among others. Today's webinar will be presented by Earth Network's meteorologist, Anthony Sagliani. Anthony joined Earth Networks in 2015 as an operational meteorologist. He produces custom forecasts for a wide range of clients in the US and around the world. And now it's my pleasure to hand it over to Anthony.
Well, thank you very much, Anna, and I'm very excited to be with you all today. I guess we're going to jump right in and get started here with a brief recap of last year's hurricane season. Last year featured a very interesting season that was, there was one late May storm that formed before the official start of the season, and that storm was Andrea. Andrea was just a weak subtropical storm that did not impact the US in any real meaningful way. Then in July, we had Hurricane Barry, which made landfall on the 15th along the central Louisiana coast. Main impact from Barry was severe flooding in Louisiana and Mississippi. Some areas actually got up to about 20 inches of rain there. And those two systems were the only activity for the first 2 months of the season, actually. Then most of the rest of the activity happened from late August through October. This included Hurricane Dorian, which was a Category 5 hurricane that absolutely devastated parts of northern Bahama Islands in the beginning of September. And here is an incredible photo from a hurricane chaser named Jim Edds, who was in Hopetown on Elbow Cay, located there in the northeastern Bahamas when Hurricane Dorian made landfall. And what you see here is Jim holding up his watch, which is measuring barometric pressure, and it's reporting a stunningly low 911 millibar reading. And for reference, Hurricane Katrina made landfall back in 2005, and the pressure at landfall with that was 920 millibars. So this was even lower. And he is in a clear blue sky of Dorian's eye, surrounded by all this destruction. And in the distance, on all sides, he's also surrounded by 55,000 foot clouds, and that is the eye wall of Dorian. So really, this is just an incredible photo and a view that few people on Earth have ever witnessed. So all in all, there was a total of 18 named storms in 2019, 6 hurricanes, 3 major hurricanes. We were spot on with our forecast for the number of hurricanes and major hurricanes, but off on our named storm totals. We had the right idea with the very quiet first part of the season, but the relentless nature of the second half was a little bit less than anticipated. Now, before we dive into typical climatology of Atlantic storm formation, now's a good time to mention that we are already sort of watching the potential for development near the Bahamas for this upcoming weekend. We have a disturbance that's going to pass through the Florida Straits today and on Friday. This disturbance is going to possibly bring some very heavy rain, isolated flash flooding over South Florida, mainly south of the Point St. Lucie area on Friday. And there's a good chance that this system will become a subtropical depression or even a subtropical storm near or north of the Bahamas. But if the system does develop, it's likely it will stay far enough offshore and not to pose any kind of threats to the United States. So with that in mind, taking a look at climatology of Atlantic tropical cyclones, occasionally we do have weak systems develop before June 1st. These are usually, as I mentioned, subtropical in nature, meaning that they're not fully tropical. They're sort of hybrids between what a tropical system and a sort of just a regular low pressure would be. And they usually only last a short while. You can see that by far the peak of activity occurs in September with occasional late year storms through October. Every once in a while, we do actually get a storm in December as well. And breaking down climatology by month, we can see that these early season storms are likely to occur close to the United States, such as the one I just mentioned that we're potentially watching. They would occur in the Gulf of Mexico and perhaps just off the southeast coast. As early months of the season go on, areas of possible development then spread deeper into the Atlantic. And by August, the most likely areas of tropical development move from the Gulf of Mexico to the northeastern Caribbean and down through the southwest Atlantic Ocean. And moving into September, you can see that this is easily the most active month of the typical season. Tropical storms and hurricanes can develop anywhere in the Atlantic from near Africa to the Caribbean, Gulf of Mexico, and along the eastern seaboard. In October, we typically see eastern Atlantic, Cabo Verde storms shutting down, but storms coming out of the western Caribbean or the Gulf of Mexico or off the southeast US coast are still quite frequent. And then once we get to November, many areas have shut down for the season in terms of possible development areas, with the exception of maybe the southwest Atlantic there. Here you can see where the most climatologically favored areas for hurricanes to make direct impact on the US during any given season are. The orange and red colors have more direct impacts for the last 100 years, while blue colors actually have the least likely chance for direct impacts. You can see the South Florida as the main hotspot, followed by the Outer Banks of North Carolina, the Central Gulf Coast in Louisiana and Mississippi, and then the Upper Texas coast as well. You can also see the least likely areas to be directly impacted in any given season are the sort of the Florida Big Bend region, the Georgia coast, then up to the Mid-Atlantic coast from Delaware to Maryland and into southern New Jersey. And you can see the theme there. Any areas where there's sort of a big bend in the coast, they're kind of less likely to see any kind of activity. And here we see landfalls from hurricanes in the United States since 1950. Last year, we touched on a few slides back that Hurricane Barry hit the coast of Louisiana. And we also had Category 5 Hurricane Michael hit the panhandle of Florida back in October 2018. And for reference, the last hurricane to impact the Northeast United States was still Sandy back in 2012. And you can see that none have hit Delaware, Maryland, Virginia directly since 1950. Now we're going to shift gears from typical climatology to elements of our 2020 forecast. So the key predictors that our forecast will focus on include the state of El Nino Southern Oscillation, or ENSO for short, which describes whether or not we're going to have El Nino, La Nina, or neutral conditions, which is sort of in between El Nino and La Nina. We will discuss the Atlantic multidecadal oscillation, which describes the average sea surface temperature anomalies in the Atlantic Ocean. We're also going to debut our new statistical forecast model we developed this year for this year's forecast. We'll take a look at any analog years that our team created and take a quick look at any possible interference that may happen on the season from Saharan dust. So first, let's talk about ENSO. As I hinted at in the last slide, there are sort of three flavors of ENSO. Either ENSO is neutral, meaning sea surface temperatures in the Central and Eastern Pacific Ocean are near normal, or the sea surface temps are above normal in the Central and Eastern Pacific, which is called El Nino. If the sea surface temperatures in the Central and Eastern Pacific are below normal, then we call that La Nina. The reason these water temperatures are important is because they're actually sort of coupled to the atmosphere and can alter weather patterns in the upper levels. For instance, El Nino results in high concentrations of thunderstorms over the Central and Eastern Pacific, which then produces strong upper level winds that sort of torque up the subtropical jet, and then flow into the Caribbean and tropical Atlantic. And then they actually prevent tropical systems from developing in those areas that we call sort of the main development region. And on the other hand, La Nina causes the opposite of those effects I just described, meaning that the upper level winds over the Caribbean and tropical Atlantic are weaker and more conducive for tropical development. And then, of course, neutral conditions, which is again is in between those two, La Nina and El Nino, mean that generally normal amounts of wind shear, at least contributed by ENSO, can be expected. And taking a look at what global climate models are showing for the upcoming hurricane season, we can see that most are showing weak La Nina to more so sort of neutral conditions. But as I hinted at, some do get close to weak La Nina. But overall, the theme is there's still a lot of spread and possibilities here. And here you can see sort of a brief summary of what I just said. What happens if La Nina develops? Well, the key takeaway is that there'll be more hurricanes due to weaker vertical wind shear and trade winds and less stability. And sort of the opposite would be the case if El Nino happens, which we're not expecting this year. Next, we're going to define an important term that will be referenced through the rest of this outlook. And this term is called accumulated cyclone energy, or ACE, as it is commonly abbreviated. ACE measures total overall seasonal activity as it factors in both intensity and duration of named storms. For perspective, the average annual ACE value since 1950 is 104 units. And I highlighted here with a circle there in 2005, the total ACE for that season, which was just under 250. And as many know, 2005 is considered the most active hurricane season on record. And you can see that indeed, in terms of ACE, it is among the highest in the last 169 years there. And then overall, ACE is a good measure of the scope and magnitude of a hurricane season. And as I said, we're going to be mentioning ACE going forward here. Now, keeping ACE in mind and looking at historic different ENSO conditions, we can see La Niñas favor more ACE and thus more active hurricane seasons, while El Niños actually favor less ACE and less active hurricane seasons. And the stronger the La Niña or El Niño, the better the chance of hurricane season being active or inactive. You can see that it just sort of cascades downward from a strong La Niña, which is the most favorable, to strong El Niño, which is the least favorable. And ENSO isn't the only story, though. We still need to address the Atlantic conditions leading up to the hurricane season. And the best measure of this is by looking at the Atlantic multidecadal oscillation, or AMO for short. There are two versions of the AMO out there that are typically referenced. The first is the NOAA version, and the second is the Colorado State University version. You can see that both, based on this graph, both generally run in unison, but the NOAA version is generally reflecting warmer anomalies. And presently, the CSU version is strongly negative, while the NOAA version is actually strongly positive. Based on our own studies, we've seen that the NOAA version seems to be a better match for forecasting tropical activity over the last decade or so, and the NOAA version is therefore the one that we're going to be using in this forecast going forward. And now, so when we combine the effects of ENSO and AMO, we get a true look at how each phenomenon impacts seasonal Atlantic ACE, and thus active or inactive. And both AMO and ENSO therefore modulate tropical activity. So stronger La Niñas and positive AMOs favor more active hurricane seasons. Stronger El Niños and negative AMOs favor more inactive seasons. You can see, just as the graph I just presented earlier, it sort of cascades down there. And anytime you have a strong Niño, regardless of whether you have a strong AMO or not, a positive AMO or not, you're going to be looking at less activity. So having discussed sort of the groundwork here, this is what went into our forecast methodology for 2020. Essentially, we chose 5 analogs with similar expected atmospheric and oceanic conditions for the expected June to November period we have coming up. We used our chosen analog years to compute average of ACE, named storms, and hurricanes, and major hurricanes. And then we sort of used our 2020 statistical model to combine that with the statistical model, or with the analog years. And our statistical model was developed to both basically increase our forecast methodology diversity and to aid our forecast success. And the model sort of spans 1980 to 2019, which is the period it was developed on. And the model predicts the same things that our analogs will predict, which is going to be seasonal ACE, number of named storms, hurricanes, and major hurricanes. And as I said, basically our methodology is to combine those, the output both of those, and get a final average. And then if a final adjustment is needed, then make that at the very end. And most of the predictors that go into the statistical model involve ocean water temperature anomalies in key locations in the Atlantic. And here, with all these arrows sort of pointing, you can see that most areas in the Atlantic are above normal. And this is setting a strong stage for what we expect for the season ahead. And you can sort of see that the Central Atlantic, or the Central Pacific, where we would be talking about ENSO, is just sort of a white color, or no anomalies at all, which is reflecting ENSO neutral. And further, just to look at what the model data is indicating, we can see that sort of a combination of all the global agencies, this model called the C3S, is showing that basically the entire Atlantic Ocean is going to be above normal through at least the June through September period. And this model is showing continued above normal temperatures across the whole Atlantic, as I said, and in the Pacific, it's showing that sort of near normal to slightly below normal, which would reflect neutral to even weakly La Nina conditions. As I said, we'll briefly talk about the possibility of Saharan dust transport having an impact on the season. Just real quick, African dust can stabilize the atmosphere, reduce incoming solar radiation, has a net effect of basically inhibiting thunderstorm growth, which is needed for a tropical cyclone development. And for the 2020 season ahead, the risk posed by Saharan dust generally appears to be near average based on additional model output from the model I was just speaking of a couple slides earlier. It sort of shows soil moisture in the lower Sahel could be lower than average in some areas, but generally the model is also forecasting above average precipitation just off the coast. So there could be some dust episodes early in the season, but in general, what this suggests to me is that dust isn't going to play that big of a role later in the season. And then based on observed sea surface conditions and modeling discussed in the last several slides, the team arrived at a total of 8 analogs that matched the likely conditions to be observed over the course of the upcoming hurricane season. Many of these chosen analogs suggest an active season is ahead, as you can see here. And the mean ACE of the analogs, which is actually 143, which is above normal. Normal, of course, being 104 there. And then the analog mean of named storms was 16 named storms, 8 hurricanes, and 4 major hurricanes. And again, all of those are above the normals that you can see here. And our statistical model is forecasting an ACE value of 156 for this upcoming season, with 15 named storms, 8 of which become hurricanes and 4 of which become major hurricanes. And taking an average of both of these analog and statistical model, we get 150 ACE, 16 named storms, and 8 hurricanes and 4 major hurricanes. So just to recap real quick before I go into the final forecast, our methodology here is basically we have ENSO in the neutral phase is what we're expecting for this year, and we expect it to have a neutral impact on the forecast. AMO is positive and will likely stay that way through the summer and fall. This has an enhancing forecast or an enhancing effect on our forecast as well. Our statistical model is suggesting an above normal season, and the team's chosen analogs are also suggesting an above normal season. And then finally, I expect the Saharan dust to sort of just have a neutral impact, neither above or below normal on the forecast. So here it is. Our final forecast slide shows the typical normal values for the last 70 years versus what we expect to happen for 2020 season ahead. We're forecasting a seasonal ACE value of 150, plus or minus an error range of about 57 on either side. We're expecting 16 named storms, plus or minus 4 on either side. We're expecting 9 hurricanes, plus or minus an error of 3. And then finally, 4 major hurricanes, plus or minus an error range of 2. And basically, this forecast equates to then a 67% chance of above normal hurricane season, 25% chance that the hurricane season ends up being normal, and only an 8% chance that the hurricane season ends up being below normal. Then real quick, what does our forecast look like if you were to think of it spatially? Well, this is plot is based on ACE versus the named storms over the last 70 years. The 2 orange dotted bars represent normal ACE and the normal number of named storms for the season. And the highlighted area in red is the sort of the forecast space where factoring in any potential forecast error, somewhere inside that red area, with the expectation that it will be in the dead center, is where we expect the final numbers at the end of the season to end up in terms of both ACE and the number of named storms. And just for reference, I also have 2 more slides in here that you guys can take a look at when the slide deck becomes available. I won't go into too much detail here. It's basically some technical definitions And the last slide here sort of shows how well our model verifies when we forecast backwards, basically, in terms of ACE. And just real quick, the Pearson correlation coefficient here is R is equal to 0.6, which basically indicates a strong correlation that our model is very significantly skilled. So that's what I have here, and now I'll turn things back over to Anna, and we'll be happy to take a few questions. Anna?
Hi, Anthony. Thanks so much. That was really great, very informative. So we do have time for some questions, and we encourage you to write those into the questions panel right now. Also, while you're asking your questions, we do have another webinar coming up next week, and that's our summer outlook. And the summer outlook will be on Thursday, May 21st at 2 p.m. And so we hope you can join. If you're interested, you can chat us in the question box, and we'll make sure you get an invite to that webinar. But let's just jump in, because there are quite a few questions that have already come in. So the first question is, your forecast indicates that the 2020 hurricane season will be above normal. Does that also mean that there is an increased risk of hurricanes hitting the United States?
That's actually a very good question. There's been quite a few studies that have been done, whether above normal or below normal season equates to above normal, below normal number of storms impacting the coast. And some of those studies are hit or miss, but in general, what it amounts to is if you have more storms than normal forecast, then the odds increase that there could be an impact on the United States. So in general, with us forecasting an above normal season, especially with all the warm waters along the eastern seaboard, it does sort of look like there's probably an enhanced threat for hurricanes and tropical storms to make landfall in the United States this year. I would say yes.
All right, the next question is, and there are actually quite a few questions around this, but what impact, if any, would a hurricane have during areas that are still in quarantine or in a COVID-19 recovery?
That's a very interesting question. I know quite a few emergency managers out there who have already been touring with that question as sort of their biggest fear. And rest assured that they are certainly planning for that sort of thing. Obviously, it would be quite a challenge to socially distance if everybody's sort of forced to be in a shelter. But you know, in general, from what I hear, that is being planned for, especially with the news of the hurricane season being above normal. And it may just be that they end up having more shelters and things like that. So I'm not exactly too sure what the right answer is there, but certainly it is being planned for, as far as I hear.
Okay, thank you very much. The next question is about, sorry, there's quite a few questions here. It's about the dust. So is the dust that suppresses tropical cyclone development, is it the dust that suppresses the tropical cyclone development, or spurious correlation with subsiding air?
Really, I mean, it's a matter of both of them. It's easier to just say that the dust is what suppresses the tropical cyclone development, because it sort of inhibits the thunderstorm growth by heating up, by allowing the sort of mid levels of the troposphere to heat up and suppress thunderstorm development. But you know, in general, no matter how you look at it, it's sort of the fact that if there's more dust, there's more likely to be less activity. So that's generally the key takeaway.
Okay, the next question is, are intensity levels of storms expected to increase, larger or more powerful?
Well, that's still a matter of debate among basically all the scientists out there. Really no correlation I've seen yet that indicates that storm intensity is going up or anything like that. We are right now in a positive AMO since 1995. And since 1995, there has been quite a few very strong hurricanes, and there was a bit of a gap for a few years in the late 2000s, early 2010s, But even in recent years, there's been a number of Category 5 hurricanes. Even last year, there were actually two Category 5 hurricanes, Hurricane Dorian and Hurricane Lorenzo. And just basically since there's an abundance of above normal water temperatures associated with this positive AMO, until it switches negative, which could be still a number of years off, we're not really sure. We expect to see more strong hurricanes, at least through the next few years, I would say.
Okay, the next question is, could anything cause the storm that is currently below Florida to turn toward the southeast coast?
Well, there's an awful lot of model solutions right now. I was looking at, before I came on here to do this webinar, I was looking at the ECMWF model, basically the European version, and looking at the ensembles. And most of the ensembles take it on a track that sort of goes out to sea very slowly away from the United States. And that's sort of the track that I would favor at this point. Sort of a weak, probably becomes a subtropical storm and heads out to sea, generally 800 miles or so offshore. It may actually even be absorbed by a storm that's going to be developing over New England or over the Northeast sometime early next week. That still remains to be seen, but I certainly don't see this thing really impacting the United States right now, with the exception of some localized flooding down in South Florida, mainly tomorrow.
Okay, and we'll make this one the last one since we've run over a bit, but we'll follow up with the rest of the questions. Is there any modeling on potential timeframes of the storms?
Well, not really. As you can see, we're already potentially off to a rather fast start to the season here, with a storm possibly on the horizon just even this weekend. But in general, in terms of when storms occur, it's more sort of related to things like the Madden-Julian oscillation and other sort of things like cold fronts reaching the Gulf of Mexico, or any number of different things when hurricanes actually start getting going. Another is when the African easterly waves actually finally start coming off the coast of Africa. That tends to start occurring late in August into September. And that's the main reason why sort of September ends up being the most active month, is because we get all these African easterly waves, and they start heading into the main development region and developing, and basically anywhere in the Atlantic you can get development at that point. So mainly I would say sort of expect it to follow climatology right now. That's the best I can say.
All right, well, there were a number of additional questions, and we'll follow up with those questions by email. Thank you so much. I'd like to thank Anthony Sagliani for that great outlook, and we thank everyone for joining us today, and we hope everyone has a wonderful rest of your day. Thank you.
Yes, thank you very much.